electricity. So here is the first part of the question. The figure below shows a traffic light supported by two cables. We want to determine the resultant of the two forces in the cables, the resultant, and also calculate the weight of the traffic light. So what we want to calculate is the weight of this traffic light. So how do you go about this question? First thing first is you need to take a point and look at all the forces acting about that point. I'm going to get this point where all the forces are intersecting. So this one here, that is a point. Look at the upward forces, the downward forces, and also the forces which are going in the X. So the downward force that we have here is the weight of the traffic light. Let me say W. That's the weight of the traffic light. We also have, let me call this as tension 1. There's going to be tension in this cable. The force found in a cable is tension. And in this cable also there's going to be tension, so that is going to be tension 2. Now, for this other cable here, T1, it's going to have components. There's going to be a component in the X. So you are going to break this into components. There's going to be a component like this. This is going to be T1X. And then there's going to be a component going up. That is going to be T1Y. Same way with T2, there's going to be a component in this direction. That is going to be 2T, T2X. There's also going to be a component going up. That is going to be T2Y. Because the angle here is 45, meaning that also here the angle is 45. That is what we need to take note of. So, meaning that the components in the X, we are going to have X component going in this direction. That is T2X. And then there is also another component in this direction, T1X. We have got two Y components up. I've got T1Y, another one, T2Y. Now, how do you calculate these components? X component is given by the magnitude of that tension cosine the angle theta. Y component, you just change where there's cosine, you put sine. So look at the net force in the X direction and the net force in the Y direction. Starting with the net force in the X direction, look at what is going in the positive X. You know that for the X or Y plane, positive X is there. So positive X, we have got T2X. We are going to remove what is going in the negative X, and that is T1X. But because this thing is not moving in any direction, meaning that the X component of the tension is going to be equal to 0, because the net force is given by mass times acceleration. Because this object is not moving in the X, the acceleration is 0. So 0 times mass, that is why we're getting the net being 0. And that is going to be 2T2X minus T1X. I'll take T1 the other side. That gives us T1X is equal to T2X. But how do we find T1? T1 is given by the component T1 cosine the angle theta. The component T1 cosine the angle theta. But what is T1? We can see, we said, remember that T1 is this one, this is T2. So T1, the component is 60 newtons. So that is going to be 60 cosine the angle, cosine theta. But theta, what is theta? Theta is the angle that this is making. We said that the angle here is the same as that angle on top, that is 45. And this should be equal to T2 cosine. And T2 there is also 60. And then cosine the angle there is also 45. So you see that these two answers are the same. But our interest for finding the missing term is to use the components in the Y. So net force also in the Y is going to be, let's get first what is going in the positive Y. So I've got T1 y, add also T2y, remove what is going in the negative y, that is the weight. Net force in the y, because this thing is not moving up or down, the net force is also 0. And T1y is given by T1 sine theta, but T1 is 60 newtons. So that is going to be 60 sine, the angle is 45, plus T2, T2 is also 60 sine 45, and then now minus W. Okay, so we are going to punch 60 sine 45, 60 sine 45. So that is going to give us 0 is equal to 38.5. But because this and this is the same, so if I punch 1, just multiply it by 2, it will give me the sum for both. So that is going to be 77.1345 minus W. I'll take W the other side, meaning that weight is going to be equal to 77.1345 newtons. So this is the answer to the second part. Calculate the weight of the traffic light, that is the weight. The first part was saying determine the resultant of the two forces or tensions in the cables. So the resultant of the two tensions, how do you find the resultant? You need to add the x components alone and the y components alone. That will give you the resultant. So let's go and do that. So I started by answering the second part of the question. That is how you answer it. We need to find the x component of the two tensions, but the x component of the two tensions is going to be the same. So Tx is going to be T cos theta, and that is 60 cos 45. We punch that 60 cosine of 45, that is going to give us 42.43 newtons. Let's find Ty. Ty, the y component is going to be 60 sine of 45, and that is going to give us also the same answer, 42.43 newtons. So to find now the resultant, we need to find the resultant in the x and the resultant in the y. So resultant tension in the x is going to be, let's add the x components. One x component is going in this direction, the other one is going in this direction. So if we take one as positive, the other one is going to be negative because they are going in opposite directions. So it's going to be 42.43 minus 42.43. That is going to be 0. And then the resultant tension in the y, but both are going up. So just add both of them in the y. Okay. So that is going to be 42.43 plus 42.43. And that is going to give us 84.86 newtons. Now when you know the x component and the y component, when you are finding the resultant now, not in the x, not in the y, the resultant is given by the square root of the resultant in the x squared plus the resultant in the y, you also square it. So what you are going to do is simply get 84.86, you square it, plus the one in the x we found is 0, you square it, and then you square root. So the answer will just be 84.86 newtons. So that is it. And then the second part of the question, determine the tension developed in each cord required for equilibrium of the 20 kg lamp. So this is the lamp and we've been told it is 20 kg. You want to find the tension in each cord. To be able to determine the tension in each cord, we need to take a point at a time. So let me take this point here. We look at all the forces acting on it. So for this point, we are going to have a component in this direction, that is T2. This T3, we can break it into components. We're going to have T3y. We also have T3x. And then also T4, we're going to have T4 going down and T4 going in this direction. So we're going to have T4 in the y and also T4 in the x. So I've broken that into components. I'm going to remove this. I can get the other point, this point here. We also break it into components. And the first force that we can see going down is this F. We also have the x component of T1. So that is going to be T1x. T1 is at an angle, so it also has a y component. So that is going to be T1y. And then the other direction, we only have T2. Okay, like that. T2 doesn't have x and y component, just has x. So now having found this, we can now work with each point. Starting with this one, let's start with the net forces in the x direction. Net force in the x is going to be equal to 4. Let's get what is in the forward x, that is T2. Remove what is in the negative x, that is T3x and the T4x. The net force is going to be equal to 0 because there's no movement here. And that is going to be T2 minus. But how do we find T3x? Remember, x is always T cos the angle. Remember, for T3, the angle that you want to use is this angle here. But what is that angle? How do you find that angle? We can do some simple mathematics calculations here. If this angle is 45, it means that this one also here is a 45. Another thing that we know is that we can actually make this straight like that, and this is 180 degrees at this point. And if it is 180 degrees, it means that this one here is 90. So if this is 30, it means that this one here is a 60. Okay. And then after determining that, what else can we use here? And then we can as well write something straight like that. Remember, our aim is we're just determining the different angles which are present here. So if I extend going all the way up to down here, this is going to be 90 degrees, meaning that this angle here, what will be this angle? This angle is going to be 45 also, because if we add this angle and this angle, we're supposed to get a 90. So this is 45. Now, because this is making a 90 degrees here, look at this is a 90 degrees. If this is 45, it means that even this angle, we already determined that it was a 45. Actually, that's just a confirmation. Another thing that we can determine, which one can we use? Okay, we've been given actually the triangle here, so it is easier because it would be hard for us to find the angle that we want. I've tried to find it, but it will be a bit tricky. The angle that we want is this one. But we know that this side is 5. You can see that number, and then this side is 4, and then this side is 3. We can use that triangle. If it is like that, it means that also this bigger size is 5, this bigger size is 4, and then this side is a 3 for this triangle that you can see here. And we have just said that T3, the x component of T3 is going to be given by T3. Remember, x component is what? Cosine theta. But according to SOHCAHTOA, how do you find cosine of an angle? Cosine is given as by adjacent over hypotenuse. The adjacent is not this one. The adjacent is 3. The hypotenuse is 5. So that is going to be 3 over 5. So this is what I'm going to substitute where there is T3x. I'm going to put 3 over 5 T3 minus, we're going out it to T4. If we go to T4, look at T4. The angle that we are interested in using when we are talking about T4 is this angle. Always use the angle that is related to the x-axis, and that is a 45. Okay, so then T4, it means that T4 in the x is going to be T4 cosine of the angle. The angle there is a 45. That is the angle that we've been given here. Okay, and another thing that you need to take note of. All right, I think that is okay. We can go on. So this is going to give us 0 is equal to T2, and this will just be an equation like this with unknowns. T3 minus, we'll punch cosine of 45. That is a 0.707 T4. So this is going to be the first equation. I can take these two terms the other side and make T2 the sub to the formula, so that is going to be, what is 3 out of 5? That is a 0.6. So that is going to be 0.6 T3, because it's going the other side, so it becomes positive, and then the negative 0.7 will also become positive. This is the first equation. And then we are going to go in the y. Remember what we are dealing with here? We are the components in the x. Now, the components in the y, we are going to have what is going in the positive y. You can see in the positive y, we have only T3. So the net force in the y, up we have got T3y, down we only have T4y. Net force is 0. T3y is going to be given by T3 cosine of theta. T4y is going to be given by T4 cosine of theta. 0 is equal to T3 cos. Now T3 cos theta. For T3, remember we said that the angle that we are using is this one. And cosine of an angle is given by, actually this is in the y, sorry for using cosine. This is y, we use sine. So sine of theta is given by opposite over adjacent. This is a 4, which is the opposite. Not over adjacent, but over hypotenuse. The hypotenuse is a 5. Then minus T4. Now sine of theta for T4. T4, the angle that we are using is a 45. So we'll just say sine, the angle is 45 there, theta. What I'll do is I'll get T4 and take it to the other side. So what are we going to end up with? We're going to have positive T4 cosine of sine of 45, and sine of 45 is 0.707 T4. That will be equal to 4 over 5 is 0.8 T3. This is going to be another equation. So that is it dealing with this point. And then we'll go to the other point. So for the other point, let's deal also with the x, the net force in the x. Forward x, we have got T2x. That's actually T1x, not T2. And then back, we have got T2. And the net force is supposed to be equal to 0 also. T1x. T1x, look at the angle we are using, is a 30. So that is going to be T1 cosine of 30 minus T2. I'll take T2 the other side, so that will be T2 is equal to cosine of 30 is a 0.866 T1. So this will be another equation. T2 is equal to 0.866 T1. Let's now work with the y direction. In the y direction, the net force in the y will get what is going up, that is T1y, minus what is going down is F. Now F is basically the force, and force is given by mass times gravity. Net force is 0, and that will be T1y is going to be T1 sine the angle there is a 30 minus mass we've been told is 20 kg. Make sure that it is in kgs, multiply by gravity, which is 9.8. Sine of 30 is 0.5. So this is going to be 0.5 T1. What I'll do is I'll get this number and take it to the other side to become positive. So 20 times 9.8, that is going to give us a 19.6. Divide both sides by 0.5. T1 therefore is going to be 19.6 divided by 0.5, and that is going to be a 392 newtons. So we have found T1, 392 newtons. The next thing we should be able to find is T2. How do you find T2? Go in the third equation, which is written down here, where there is T1, we are going to substitute the value that we have just found. So that is going to become T2 is equal to 0.866, where there is T1, we substitute 392. And so that is going to give us 392 times 0.866. That is going to give us a 339.5 newtons rounded off to one decimal place. After finding that, we can come and now find the other terms. So I'm going to come in this equation where there is T2, I'll substitute what I found. So that would be 339.5 is equal to 0.6 T3 plus 0.707 T4. Okay, this is the equation that we are going to end with after we substitute in this one that I've just removed. Now what I'm going to do is that I'm going to make T4 the subject of the formula in this one here. So I'll have T4 is equal to, what I'll do is I'll divide both sides by 0.707. So that will be 0.707, also this side 0.707. So that will give us T4 being equal to 0.8 divided by 0.707, and that will give us like a 1.1315 T3. So where there is T4 in this equation I've written here, I'm going to substitute that. So this will become 339.5 is equal to 0.6 T3 plus 0.707. Where there is T4, we are substituting 1.1315 T3. So this will give us 339.5 is equal to, first thing is I'm going to multiply this. That is going to give us 0.8. There's actually a plus here, 0.8 T3. Then the next thing is I'm going to add those two terms. So this will be 339.5 is equal to 0.6 plus 0.8. That will be 1.4 T3. To find T3, divide both sides by 1.4. So 339.5 divided by 1.4, that is going to give us a 242.5 newtons. And then the last one to find is T4. T4 is 1.1315 times T3, and T3 we have found 242.5. So simply multiply 1.1315 by 242.5. Okay, 1.1315 by 242.5, that is going to give us 274.4 newtons. So these are the values. This is T4, this is T3, this is T2, and this is T1, and that is it for this.